Next topic is limits. We'll see in this topic why we need the concept of limits and when we use the limits. Okay, so suppose you have a function f of x is equals to 1 upon x minus 3. Okay, we have this function. Suppose we want to calculate f of 1. What will be f of 1? It will be 1 upon 1 minus 3, which is 1 of minus 1 upon 2. Suppose we want to calculate f of 5. So what will be f of 5? It is 1 upon 2. Now, if you want to calculate f of 3, what will be f of 3? It is f of 3 which is 1 upon 0, and 1 upon 0 is not defined. Don't be confused that 1 upon 0 is infinite. This is wrong. 1 upon 0 is actually not defined. It is not infinite. Okay, infinite is quite different from not defined. Okay, so in this case, we need the concept of limits. Now, we can't calculate the value of function at x is equals to 3. But what we'll do, we'll try to find the nature of the function or behavior of the function or value of the function just before 3 and just after 3. Okay, so when we'll find the value of function just before 3 and just after 3, we'll introduce the concept of limits. For example, suppose whatever function is, suppose we have any function. If you take the example of this function or any other function, suppose we have a function like this. Okay, now suppose this is an example. We have any function. Suppose f of x is this. This is not the graph of this function. We have taken in general any function. Okay, so now this is suppose x is equals to 3. If you draw the graph of this function, we will discuss about this also. Suppose so at this point 3. Now if we want to calculate or we want to know the behavior of the function just before 3, that is when x is approaching to 3 but from left. Notice the statement, x is approaching to 2 but from left. So this is denoted by x tends to 3 minus. Okay, x tends to 3 minus, that is x is approaching to 3 but from left. That's why we are saying this is left hand limit, and we write this in this way: limit x tends to 3 minus f of x. What is this? That is, we are calculating, we are trying to evaluate value of function just before 3 or when x is approaching to 3 but from left. Okay, it doesn't mean that we are calculating the value of 3. It means 3 के जितने close हम जा सकते हैं उतना close but from left. Okay, similarly when you evaluate the value of function at x but from right, okay, at x is equals to 3 but from right, so it is represented as x tends to 3 plus, this is limit x tends to 3 plus f of x. Okay, so what is this? When x is approaching to 3 but from right, this doesn't mean that 3 is negative and 3 is positive. No, this is 3 is approaching to x is approaching to 3 but from left, and this is x is approaching to 3 but from right. Okay, so when x is approaching to 3 from right, the value of function, and this is value of function when x is approaching to 3 but from left. This is called left hand limit. Okay, and this is called your right hand limit. Okay, so this is actually this when we use the concept of limits to know the behavior of the function, what is going in the function, what will be the behavior of the function just after and just before. This was at x is equals to 3. Now in general, if we say at x is equals to a, limit x tends to a, f of x exists, what will be the concept? So in that case, at x is equals to a, limit x tends to a exists, then we say LHL equals to RHL. Okay, LHL is equals to RHL, where LHL means limit x tends to a minus f of x. Okay, and RHL means what? RHL means limit x tends to a plus f of x. Okay, now we'll introduce the concept of h here. What is it? Look, now just we see the example, limit x tends to 3 minus f of x. We say this is LHL. Okay, now if this is LHL, now we are introducing the concept of h. H is approximately 0 and h is greater than 0. In measure of the books we use concept of h, but in few books you can find also epsilon. Okay, now what is this? Now limit x tends to 3 minus f of x, that is value of f of x when x is approaching to 3 but from left. It can also be written as limit h tends to 0 f of 3 minus h. Look at this carefully. Limit h tends to 0 f of 3 minus h. What is this? And what is this? If you see, x is approaching to 3 but from left, that is 2.999999, we have calculated the value of function at 2.999999, which looks absurd that we are calculating 2.999999. So what we have introduced the concept here, limit h tends to 0 f of 3 minus h. These both are things similar, just it makes the calculation easy. If we use the concept of f of 3 minus h, f of a minus h, it makes the concept of calculation, it makes the calculations easy. Okay, so this and this is same. If h is approximately 0, that is 0.00000001, so 3 minus 0.00000001 will give you 2.999999. Okay, so similarly, if you use the concept of RHL, it is RHL. What was RHL? Limit x tends to 3 plus f of x. So it will also be what? Limit h tends to 0 f of 3 plus h. Now it is giving the value of f of x when x is approaching to 3 but from right, that is 3.0000000001. Similarly, it is what? 3 plus 0.00000001. This is also the value of f of x at x is equals to 3.0000000001. So in limiting case, what we will say, when x is approaching to 3 but from right, this is the concept. When x is approaching to 3 from left, this is the concept. So in general, if we use here at x is equals to a, so limit x tends to a minus f of x is equals to limit h tends to 0 f of a minus h, and it is what for RHL? Limit h tends to 0 f of a plus h. Okay, so when LHL equals to RHL, we say limit exists. If LHL not equals to RHL, then we say limit does not exist. Let's understand this by taking an example. Check whether limit x tends to 0 f of x exists. Okay, where first part is f of x is equals to 1 upon x, and second part is f of x is equals to 1 upon x square. Okay, we can understand the concept of limits from these examples in a very good manner. Okay, so for first function we'll calculate at x is equals to 0, we are calculating LHL. When you calculate LHL, it is limit x tends to 0 minus f of x. Just like we write the formula, general formula, limit x tends to a minus f of x. So it is, if you use the concept of limit h tends to 0 f of a minus h, that is f of 0 minus h. Most of the times when you solve the question, you forgot to write f here. So focus, it is f of 0 minus h. Now when you find f of 0 minus h, first function is f of x, so f of minus h will give you what? Limit h tends to 0, f of minus h will give you what? 1 upon minus h. And now put the value of h is equals to 0. Keep in mind, h is not exactly equals to 0. If h is exactly equals to 0, it will be not defined. Okay, what is h is approximately 0? H is tending towards 0. So when you put 1 upon tending towards 0 will give you what? Minus infinite. Will give you what? It is your minus infinite. Okay, why it is minus infinite? If you are still confused with not defined and minus infinite or plus infinite cases, suppose just take an example. If you find 1 upon 5, it is 0.2. If you find 1 upon 2, it is 0.1. If you find 1 upon 0.1, it is 10. If you find 1 upon 0.000000001, it is 1, 2, 3, 4, 5, 6, 7, 8, 9. It is 10 to the power 9. Look, as denominator is tending towards 0, output is increasing drastically. So when denominator is tending towards 0, we will get output a very large number. That number is represented just as infinite because it is not practically possible to write a number when denominator is tending towards 0. Okay, so that number is represented by plus infinite or minus infinite. And what is actually not defined? When you got the concept 0 upon 0, 1 upon 0, 0 power 0, infinite upon infinite, infinite power infinite. So these are the concepts of not defined cases, and infinite is quite different from not defined cases. So this is what h is tending towards 0, so it is minus infinite. And when you calculate RHL, it will be limit x tends to 0 plus f of x, which is equals to limit h tends to 0 f of 0 plus h. And when you find f of 0 plus h, it is f of h. So it will be limit h tends to 0, limit h tends to 0, f of 1 upon h, when you f of, so it will be 1 upon h. Now again h tending towards 0, so it will give you plus infinite. So now look, what is LHL? LHL is minus infinite, and what is RHL? Plus infinite. So what you will say, LHL not equals to RHL, therefore limit x tends to 0, f of x does not exist. Okay, limit. Now find what is LHL here. When you find LHL, it will be what? Limit x tends to 0 minus f of x, which is limit h tends to 0, f of 0 minus h. Okay, so now it is what? Limit h tends to 0. When you put f of minus h, what will be f of minus h? 1 upon minus h whole square. So it is 1 upon minus h whole square. And when you put h tending towards 0, it will give you plus infinite, because it is whole square. Minus 1 upon h whole square will give you 1 upon h square, which is plus infinite, which is what? Your plus infinite. So what is your LHL? Plus infinite. Now let's calculate RHL. When you calculate RHL, what is RHL? RHL is limit x tends to 0 plus f of x, which is equals to limit h tends to 0, f of 0 plus h, which is f of h. So which will be what? Limit h tends to 0. When you find f of h, what it will be? F of h, 1 upon h square. So 1 upon h square, when you put h tends to 0, it will give you plus infinite. Now look, what is LHL? What is RHL? LHL equals to RHL. Therefore, what you say? What is limit x tends to 0, f of x exists. Okay, now what we have understood from these two examples, when x is approaching to the same value from left hand side and right hand side, then we say limit exists. Okay, look here, from left hand side and right hand side, function is approaching to the same value, that's why we are saying limit exists. And in this case, what is limit? Function is not approaching to the same value from left hand side and right hand side, that's why we are saying limit does not exist. Now we have seen mathematically that when LHL not equals to RHL, then we say limit does not exist, and when LHL equals to RHL, we say limit exists. Now what is mathematically, when we calculate, थोड़ी feel कम आती है, we don't get actually what is going on. Now let's see these questions graphically, actually what is going on in the question. Okay, let's draw the graph of f of x is equals to 1 upon x. When you draw the graph of f of x is equals to 1 upon x, this is the graph of f of x is equals to 1 upon x. Now look what is going on. Just before 0, function is approaching to minus infinite, as limit says LHL. When x is approaching to 0 but from left, function is approaching to minus infinite as shown in the graph. And just look here, what is in RHL? What is when x is approaching to 0 but from right, function is approaching to plus infinite. So function from left and right is not approaching to the same value, that's why we are saying that limit does not exist. Agree? Now look what is here. In this case, look, the graph of f of x is equals to 1 upon x square. What will be the graph of f of x is equals to 1 upon x square? When you draw this graph is like this. Now look, when x is approaching to 0 but from left, what is f of x? F of x is approaching to plus infinite, shown mathematically, and look at the graph. And when x is approaching to 0 but from right, what is the limit? Function is approaching to plus infinite as shown in the graph. So function is approaching to the same value but from left and right, that's why we are saying limit exists. Okay, and in this case limit does not exist. So what is conclusion here? To exist limit, function must approach to same value from left and right. If it is approaching to the same value, then we say limit exists, otherwise limit does not exist. Okay, let's take one more example to check to better understand the concept of limit. Okay, check whether limit x tends to 3 f of x exists where f of x is equals to x square minus 9. Okay, so let's check the value of function just before 3 and just after 3. Again, look at this. We are calculating what? Limit. So when you calculate limit, you will not calculate the value of function at 3. We'll calculate what is going on just before 3 and just after 3. Just before 3, that is, we will calculate LHL. Just after 3, we will calculate RHL. Let's find LHL. What will be LHL? When you calculate LHL, it will be what? Limit x tends to 3 minus f of x. And what is it? Limit h tends to 0, f of 3 minus h, according to formula. It makes easy. When you introduce the concept of h, it makes your calculation easy when you have some typical problem. Okay, otherwise you will not use h. It is also acceptable. Then you have to put your extra brain to solve the question. But if you use h, question will be solved very easily. Okay, so that's why we are using the concept of h. Now what is f of 3 minus h? Don't forget to write here when you solve the question. Okay, so what you do, you forget to write f here. If you forget to write f here, it doesn't make any sense. So always put f here. So f of 3 and minus h. So f of x is x square minus 9. When you put f of 3 minus h, it will be what? Limit h tends to 0. Limit h tends to 0. F of 3 minus h is 3 minus h whole square minus 9. Now put the value of h if you are not getting any undefined format. When you put h is equals to 0, it is h. When you put h is equals to 0, this is what? 3 minus 0, 3 square is 9, 9 minus 9 is 0. We are not getting any undefined format, so you can put the value of h. So it is what? 0. Now, if you calculate RHL, what will be RHL? It is limit x tends to 3 plus f of x, so which is limit h tends to 0, f of 3 plus h. And when you calculate f of 3 plus h, it will be limit h tends to 0, f of 3 plus h will give you what? 3 plus h whole square minus 9. And we'll put h is equals to 0, it is 3 plus 0, 3 square is 9, 9 minus 9 is 0. Now what is, if you see simply mathematically, it is being satisfied. LHL equals to RHL. Therefore, limit x tends to 3, f of x exists. Okay, again, now let's see again this mathematically. Very interesting. This is mathematically you have got the concept that LHL equals to RHL, you will say limit exists. Now what graphically, if you see this problem graphically, you will actually feel what is going on. Okay, if you draw the graph of this function, it will be like this. This point is 0 comma minus 9, this is 3 comma 0, and this point is minus 3 comma 0. What we have calculated, limit x tends to 3. So we'll check the value of function just before 3 and just after 3. Let's see in the graph. Just before 3, function is approaching to 0, and just after 3, function is approaching to 0. As we have found in LHL, it is 0, RHL is 0, and look in the graph, when x is approaching to 3 but from left, function is approaching to 0, and when x is approaching to 3 but from right, function is approaching to 0. So from both sides, left hand side and right hand side, function is approaching to the same value. That's why we are saying limit exists.